Hi, this is going to be a little lesson today about what is an acid and what is a base and what are the properties of acids and bases. Um, you can see from this reaction I have here the ionization of water, and you might think, well, water is molecular. It's not made of any ions. We know that water, kind of looks something like this, where we have oxygen and the two hydrogen atoms bonded to the oxygen, and then there's the extra electrons on the outside. But we also know that water is very polar. And sometimes if you get two water molecules and they bump into one another, sorry about that little random line right there. Sorry about that. But they will bump into one another and they are quite attracted here. Okay. This water molecule can pull the hydrogen off of the other water molecule and form this ion, which is called hydronium. Now the electron is left behind, like this pair of electrons. So the OH right here has an extra electron, and that's this ion, which is known as hydroxide. So this is a reversible reaction. The hydronium and hydroxide ion can run back into each other and turn back into the water molecules. And we know from the last unit that we were studying that, reactions that are at equilibrium, okay, reach a point where the relative amount of products, the ions, to molecules, the water molecules, stays steady. Now, in water, it's really a small ratio. Like there's very few of these ions right here compared to water molecules. Most of it's in the molecular form. But this is what creates a situation where we end up with an acid or a base, because what they're going to do here, most of the time when you see it, they'll take a water molecule out of both sides. And if you subtract a water molecule from H3O, basically the net reaction of it is that, I want my blue back, the net reaction of it is that, that you end up with basically one of the water molecules breaks apart into hydrogen ions and hydroxide ions, okay? And as long as you have like water, the amount of hydrogen and the amount of hydroxide are equal to one another, and that creates a neutral solution when your hydrogen and your hydroxide are equal to each other. But if you add something, oops, went the wrong way. If you add something to this equilibrium, like say, for example, I drop in some what's known as lye, which is sodium hydroxide, that's going to increase the hydroxide, and I'll have more hydroxide than hydrogen, and that's going to create a base. So sodium hydroxide is a basic substance and it has the properties of a base because adding it to water creates more hydroxide than hydrogen, and that solution then ends up having the properties of a base. If I add something that increases the hydrogen instead of the hydroxide, like say, for example, I bubble HCl, which is a gas. You might recognize it as hydrochloric acid, but it's hydrogen monochloride in the gaseous form. And in the gaseous form, it actually doesn't really act like an acid. Why? Because the hydrogen is bonded to the Cl, with the little, this really got messy here, sorry. Let me try this again. But, the hydrogen is bonded to the Cl. Remember, you have chlorine with its 7 valence electrons, and then the 7th one gets shared with hydrogen. So in this form, it's a gas. And one time in college, I was exposed to this, and the gas that was in the air, it didn't burn my skin or eat holes in my clothing or anything. The only places it bothered me was like my nose, my eyes, my mouth. Why? Because There, it was dissolved in the moisture in your saliva, your eyes, your nose, etc. And it could break apart into H plus ions and chloride ions and increase the amount of hydrogen ions compared to hydroxide that was in the moisture. And anytime you have more hydrogen than hydroxide, you get something that behaves very much like an acid. So all solutions that are made with like water as the solvent have both hydrogen and hydroxide in them. As long as the amounts are equal, that solution is going to be neutral. So you can take something like water and you can add some salt or some sugar, and that solution is going to remain neutral. But if you add something that increases the hydroxide, and I gave you one way that that can happen, adding something that contains hydroxide ions. So if you increase the hydroxide more than the hydrogen, you're going to have something that's basic. And we'll talk about the properties of a base in a minute. And if you add something that contains hydrogen, then like the HCl, then, and again, that's one way to increase the hydrogen. If you have more hydrogen than hydroxide, then you have something that is acidic. Okay. And so what we're going to talk about today is, what is an acid? What is a base? And this was first recognized by a gentleman named Svante Arrhenius in the late 1800s. And he certainly recognized that an acid contained hydrogen. And if you put it into the solution, then you got more hydrogen ions, which of course, now you had more hydrogen than hydroxide, so that substance would act like an acid. And he recognized that, like a base, okay, was something that contained hydroxide ions, and you put it into your solution and it would dissolve and increase the hydroxide. So now you have more hydroxide, than you had the more hydroxide, then you had hydrogen, and it would act like an acid. But once, this model for like, what is an acid? It's a hydrogen containing substance. What is a base? It's a hydroxide containing substance. They came across some other substances, like here's one. This is the formula for baking soda. Now, baking soda behaves like, has the properties like a base. You test it with litmus paper, you see, its reactions, etc. It acts like a base. But I don't see any hydroxide in there, right? There's no hydroxide in the formula. So that led us to need a second model for what is an acid, what is a base. And that one is called the Bronsted-Lowry model. And the two models, like, one doesn't replace the other one. They kind of like work together to help us describe what's an acid, what's a base. An acid can contain a H plus 1 ion, or it can donate that H plus 1 ion to something else. And a base can have hydroxide ions, or it can accept an H plus 1 ion from something else. Let's look at this chemical reaction here, and you can see that it's reversible. Okay. Like over here's your reactants and over here's your products. So you kind of have to look at like what's going on when this reactant turns into product. So do you, So do you see that as that turns into this, okay, you see that it lost this H right here because it's not there. That makes this a Bronsted-Lowry acid because it gave away its H. And what it turns into is called the conjugate base. Oh, it's not writing for me. Don't know why it does that to me sometimes. That's called the conjugate base. And then you have to look at the other substance, like here, the water. Look what happens to water as you go to the other side. It picks up an H. Instead of 2, now it has 3. So water here is actually a Bronsted-Lowry base because it accepted the H and turned into the H3O. And this is called the conjugate acid. Okay. So if you put this substance right here in water, you will get an acidic solution because you've made H3O ions, which is just H+1 ions with, water attached to it. Let's look at another example. Examine this one and see if you can figure out which one accepted the H and which one gave it away. And you can even pause and, take a good look at it. Okay, so I'm going to go on with the answers, but if you want to pause it and give it a try, because there will be some like that in the exit ticket, you could pause it, think about it. So look what happens to the NH3 as it goes over here to the product side. It picks up an H. Here it has 3 and over here it has 4. So the NH3 accepted an H. So that makes it a Bronsted-Lowry base. And that makes this the conjugate acid. And then if you look at the water, look, it lost one of the H's. Here it had 2. Over here it only has 1. It gave away an H. So that makes it a Bronsted-Lowry acid. And that makes this a conjugate base. And NH3 is ammonia that you clean with at home. It's definitely got some properties of a base, like it's very slippery. It would make litmus paper turn blue. It has a high pH, like 11, something like that, 10 point something 11. And so it's a base, but it doesn't contain OH. But if you put it in water, it increases the OH that's in the solution. And then you're kind of back to that, like, look, if there's more OH than H, it's going to be a base. So that's why NH3 is a base, even though it doesn't have an OH in its own formula. When you add it to water, it increases the amount of OH. And if there's more OH than H, then, it behaves like a base. So did you notice one thing in this reaction right here? I always think this is kind of fun and interesting. In this reaction right here, water was a base, and here it was an acid. And you're probably thinking like, hey, I thought water was neutral. And water is neutral because in pure water, the H and OH are equal to each other. But in the Bronsted-Lowry model, there are substances that can both attract an H and give away an H. And they are usually substances that are like right around pH 7. They have to have an H in the formula somewhere because you got to have an H to be able to give away an H. And they usually also have like some electrons on them somewhere that can attract an H and hold on to it. So water fits the bill. If you pair it with a base, it'll act like an acid. If you pair it with an acid, it'll act like a base. And we have a special name for those kinds of substances. They are called amphoteric substances. Now, not all substances can do that. They need to have an H to give away, and they have to have somewhere in the molecule that they can attract an H, okay? Now, why are we so interested in acids and bases? Well, their compounds have very interesting properties. Like acids, for example, they taste sour. One of my favorite candies, and if we were in class together, I would be bringing in a bag of these and sharing them, which is totally because I want to eat them too, is the Sour Patch Kids. And if you look on the ingredient list for Sour Patch Kids, you're going to see that there is acid in the formula. Now there's sugar too, which of course makes them good, but there is acid. If you taste, for example, a lemon, it will taste sour. You might say, well, lemonade's not sour. That's because we add a lot of sugar. Okay. Vinegar is acidic, tastes sour. Did you ever chew an aspirin tablet? Woo, tastes sour. Aspirin is acidic. So acids taste very sour. Bases, on the other hand, they taste very bitter. Some bases that I can think of would be like coffee grounds, baking soda, very bitter. If you don't like black coffee, that's probably because black coffee is very bitter. Again, people add sugar to cover the bitterness, just like we add sugar to cover the sour. Sugar, even though it's not that great for us, really helps to cover up some of these tastes that maybe are not appealing to us. But there are some ways that we have learned to, identify acids and bases. Like acids turn litmus paper red. Litmus paper comes in two colors, blue and red. If you put red paper in an acid, it'll stay red. If you put blue paper in an acid, it'll turn red. There's phenolphthalein. That's this big tough word right here. It stays clear in an acid, but it also stays clear in neutral. So it's not 100%. It can tell you that it's not a base, but it can't tell you for sure that something's an acid. And there are all kinds of acid-base indicators. There are some in nature, like cabbage juice. But there's all kinds of different compounds that change color depending on whether they're in an acid or a base. Acids, their solutions are conductors. That's why we put acids in batteries, because they help to complete the circuit and carry the electrons within a battery. If you add an acid and a base to one another, they will neutralize each other. If you put metal in an acid, you will get, especially if the metal is very reactive, you will get hydrogen gas. And it depends, you may or may not have seen that demonstration, but if you would like to see that, you could put, just Google asking to see like the reaction of magnesium or zinc with hydrochloric acid, and you would certainly see lots of videos with that. And acids, they react with carbonates to form carbon dioxide. If you've ever seen that little reaction of vinegar and baking soda together, baking soda is a carbonate, sodium bicarbonate, and vinegar is an acid, and they foam. Make a lot of little kids like to do the volcano thing. So they kind of foam. And what's going on there is that, the acid is reacting with the carbonate. You're getting some carbon dioxide gas, which is safe. And the other thing that you end up with then is salt water. So that's why that's kind of safe for kids, for kids to fool around with. In nature, this can kind of be a problem, because if we get too much acid rain, it'll react with things like marble and sandstone and lime, etc., that are made of carbonates and wear away rocks. The acid that's in acid rain can add to erosion, carve out caves, damage building materials and statues, etc. So we had said bases taste very bitter and feel slippery, like soap is a base. If you get that in your mouth, you're going to know what I mean by the bitter, and it is slippery. They will turn litmus paper blue. The blue paper will stay blue, and the red paper will turn blue. Bases, their solutions are conductors. So again, sometimes, like an alkaline battery, that means that it's got a base in there instead of an acid. And that base is helping to conduct. They can neutralize acids. Like, if you have an upset stomach that's caused by too much acid in your stomach, some of the different stomach remedies that you buy over the counter contain bases that will help to neutralize your stomach acid. And then if you put this compound called phenolphthalein in a base, it will turn pink. And again, if you want to see that, again, Google phenolphthalein in a base, and you'll see just this very beautiful, bright pink color that it turns. So it does help to identify if something is a base. So hopefully this helped you to see a little bit about what is an acid, what is a base, and what some of their properties are. And good luck with the exit pass.